Okay, so let's find the x-intercepts. For g of x equals 6 minus x squared. Now what we're really doing is we are solving the equation 0 equals negative x squared minus x plus 6. Or we could rewrite that as 0 equals negative x plus 1/2 squared plus 25 over 4. Because this is an alternate writing of this. They are the same function. All three of these things that I've got circled will graph to the same curve. They are algebraically identical. Let's work with this guy. Okay, so you may not like those fractions, and that's okay. We can get rid of them. We can get rid of the fractions by multiplying both sides of this equation by 4. Which means I've got 0 equals negative 4 times x plus 1/2 squared plus 25. A fraction is going to come back in a minute, but that's okay. Now, we want to isolate that squared term, so let's subtract 25. So now I've got negative 25 equals negative 4 times x plus 1/2 squared, and my fraction comes back because I have to divide through by negative 4. So now I've got 25/4 equals x plus 1/2 squared. Well, now I can square root both sides. So I get the positive or negative square root of 25 over 4 equals x plus 1/2. Well, that means x plus 1/2 equals 5/2, or x plus 1/2 equals negative 5/2. Work with both of these in turn. Subtract 1/2, and we get x equals 4/2, which is 2. Or work with the other one, and again subtract 1/2, and we get x equals negative 6/2, which is negative 3. And my x-intercepts then are at the coordinates 2, 0, and negative 3, 0. Now, you may or may not remember from previous classes that there's another way to handle this, and it actually comes out of the completing the square that we do to get to the vertex form, and that is called the quadratic formula. And the quadratic formula is kind of a shortcut to the end. And what it says is, if you have got an equation of the form ax squared plus bx plus c equals 0, you have to start with this. So if you have that, then x is always going to be found by taking negative b plus or minus the square root of b squared minus 4ac all over 2a. So if we again work with our standard our polynomial of choice here, this guy, we work with this guy, and I want to find its x-intercepts. Which is the same thing as saying solve the equation. I'm going to put it in standard form, so negative x squared minus x plus 6 equals 0. That means a is negative 1, b is negative 1, and c is 6. So I can use a quadratic formula because I have an equation that says that ax squared plus bx plus c equals 0. So then I can find x using this formula right here. So I know that x is going to be the negative of negative 1, which is 1, plus or minus the square root of negative 1 squared, which is 1, minus 4 times negative 1 times 6, all over 2 times negative 1, which is negative 2. So what I've really got inside there, so what I really have here is 1 plus or minus the square root of 25 all over negative 2. So I've got 1 plus or minus 5 all over negative 2. So that means x equals 1 plus 5 is 6, divided by negative 2 is negative 3. Or 1 minus 5 is negative 4, divided by negative 2 is 2. And again, our intercepts are at negative 3, 0, and 2, 0. All right, so that's the basics, the highlights on quadratic functions. There is some conversation in your textbook around this quantity right here. It's called the discriminant, and I referred you to your textbook for reading about the discriminant. It's pretty self-explanatory. It talks about what types of solutions you're going to find. And there are several examples in your text. If you have any questions, I encourage you to reach out to me. I'll talk to you soon. Bye.